When I first used post-processing for my VR game, I spent hours fine-tuning every parameters, and when it was time to try it for the first time, it went like this. Boom. Now, to stop you from making the same mistake that I made, I'm going to share in this video how to use post-processing for VR development in Unity. We are going to learn how to set up post-processing for both Standard Pipeline and URP and see how to improve the look but keep everything optimized. So if you are enjoying this content, make sure to like and subscribe to not miss the next video. You can always support the channel on my Patreon, where you can download the source code of all of my projects. So let's first have a look at how we can set up the post-processing for Unity. Now, this setup actually depends on the pipeline that you are using for your project. I'm going to show it for both Standard Pipeline and Universal Rendering Pipeline, but you can skip the part you want by using the time step under this video. And by the way, if you don't know which one to choose, I recommend URP, which is a bit more optimized for mobile, especially with post-processing. But if you want to use this Standard Pipeline, like in this project that I have here, we can go to Windows, Package Manager, select Unity Registry, and now we can search for post-processing. There you go, we can select post-processing here and click on Install. Perfect, now the post-processing package is installed in our project and we can close this window. Okay, now that it's downloaded, let's configure it for our scene. I'm going to create an empty game object and rename it post-processing. Next, we can add a post-process volume component, and this is where we will add all of the effects. We can set the post-processing to is global, and this makes the post-processing works everywhere and not be dependent to if the player is inside a certain zone or not. We can click on New. This will create a new post-processing profile, as you can see, and you can now add effect over there. But we have one remaining task to do, and it is to enable this on the VR camera. For this, I'm going to the camera we are using. And by the way, this works the same on all VR rig. Here I'm using the Unity XR toolkit, but you just have to select the camera you have. Next, I'm going to add a post-processing layer. By default, it takes the camera here on the trigger. And as you can see below, we need a layer that allows us to say which processing can influence this camera. So let's go back to our post-processing, click on Layer, Add Layer, create a new layer called post-processing, and now click back on our game object and then set the layer of this game object to this new layer. Perfect. Now what's left for us is to go back to the post-processing layer and add this layer over there. There you go. And now, as you can see, we can start adding the effect and it works. Okay, so this was for the Standard Pipeline. Now let's see how to use this, but for the Universal Rendering Pipeline. Now already this is easier because it's already included with the URP, so we don't have to download anything. So let's right click, create an empty game object, call it post-processing. On this game object we can add this time a volume component. It's already in global, which is good. Next, click on create a new profile. As you can see, this creates a new post-processing profile, and we can, as for the Standard Pipeline, add effect by going to add override post-processing. So for example, if I add a bloom layer and play with the setting here, we can see it is applying on the scene but not on the camera. So to fix this, we simply need to go to the camera used by the camera rig, and this is of course the same setup if you are using another SDK, and you just have to select the camera used by the rig. And here in the rendering, I'm going to enable post-processing, and tada, there you go. As you can see, it works and it is applying in the scene but also on the camera. And we have finished with the post-processing on URP. So now that we have learned more about how to set up post-processing, let's have a look at all of the effects that we have. So this list is not short, so stick with me. We have ambient occlusion that darkens specific areas of your scene, anti-aliasing that allow you to soften the edge by adding similar points around the corners, auto exposure that simulates the adjustment of the human eye when changing the brightness of a light, bloom. This is one of my favorite effects because it makes emissive areas glows, and that is super useful for that neon look. So chromatic aberration next, that split the side of the image into red, green and blue color to mimic a camera lens. Color grading, another important effect that it is used to correct the color of the scene. Next, depth of field. that blur the background to mimic a lens, grain that adds some noise to the scene, lens distortion that simulates distortion of a camera lens, motion blur that blur the camera when we move, and screen space reflection that create reflection like wet surface, but it is currently not working in VR. Finally, we have vignette that darkens the edge of the image. There it is for the overview. By the way, this list of post-processing effects is not exactly the same for the standard pipeline and URP. I don't really know why, but for URP, they have separated color correction in different effects, such as color curve, color adjustment, channel mix. Now, if you want to learn more about these effects and especially how the setting influence them, I recommend you to watch this video by Brackeys. And of course, have a look at the documentation for both URP and standard pipeline that you will find in the description below. Okay, so these effects are cool, but how do they apply for VR development? And this is when I come with a bad news, but VR hates post-processing, and this for two reasons: the immersion and the optimization. Now, we obviously know that when we make a VR game, the goal is for the player to feel immersed and not like he's watching the world through a camera. So this means that already we can exclude some of the lens effect, like lens distortion or depth of field, for example. Even more, this is especially important when taking motion sickness into account, because we don't want to use effects that might not be comfortable for the player, like motion blur or chromatic aberration. So by taking this into account, we are left with color correction, ambient occlusion, bloom, anti-aliasing, and vignette. And this is where we need to take into account the second parameter, the optimization. Of course, adding post-processing effects require additional computation that are better to avoid, but in the case of these post-processing effects, there are solutions available. So let's have a look at it. For color correction, something I recommend is actually to use all of these settings until you are pleased with the look of your game. Then take a screen, remove this effect, and now you can use this reference picture and play with the lighting settings and the material of your scene to achieve the look that you are after. So for ambient occlusion, this is a bit the same. Instead of using the effect as a post-processing, you can actually bake it in the lighting settings of your game by going here at the top, Windows, rendering, lighting, and enable ambient occlusion. Next on the list, we have bloom. This one is used a lot in VR, and the good news is that it is already not too much expensive. But be sure to disable high quality filtering for URP and enable fast mode for standard pipeline. Same goes for anti-aliasing. You can actually set it up directly here in the rendering setting of the camera for URP and select fast mode. For standard pipeline, you can do the same in the post-process layer. Finally, vignettes for once is not that expensive, so you can use it directly. And a little tip just for you is that you can use this as a quick solution to reduce the field of view on demand and reduce the motion sickness like it is done in a lot of games. So in conclusion, what you really need to get from this video is that not all post-processing effects are good to use in VR, and it's important to avoid them if you can, of course. But I'm not the one making your game, so it's important for you to take that judgment yourself by testing each one of those effects on your own. And if you want to use it, the safe ones are color correction, anti-aliasing, bloom, and vignette. And if you want to target mobile VR, make sure to set the setting accordingly for bloom and anti-aliasing, and to avoid color correction by playing with the material and the lighting of your scene. Now, thank you for watching. I hope that you enjoyed this video, and as always, if you did, you know what to do. You can also support the channel on Patreon. This is what is making possible for me to create this content. So let me know what subject I should cover next, and see you soon. Bye bye.